student. My name is Pardeep and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. Today we will discuss the subject Basics of Database Management System, whose code is KOE067. So today's topic is data independence. So it is one of the problem in flat file system that there is no data independence in flat file system, so there is less security. So in DBMS, so this concept data independence is introduced to provide different level of views. So there are basically two types of data independence. So let's see what is data independence first. So what is data independence? What is data independence? So data independence refers characteristics of being able to modify the schema at one level of database system without altering the schema at the next higher level. So it refers the characteristics of being able to modify the schema. Okay, we modify the schema at one level without altering the schema at the next higher level. So this concept is known as data independence. Okay, so there are basically two types of data independence. One is logical data independence and second one is physical data independence. So there are basically two types of data independence: logical data independence and physical data independence. So let's understand with the help of some block diagram. So see, so our database is having different level of views. First one is external level, or you can say here user level, okay, user level, or you can say view level. Here user interact with the database. Here it is the user. User interact with the database. This is the external level. Next one is the logical level. Here basically we deal with the logical schema, or you can say ER diagrams. Okay, next one is the physical level. Here we deal with the storage details. Now whatever modification we will perform at external level, okay, at external level, this will not affect at the logical level. So this is known as logical data independence. Means external level modification is independent of logical level modification. Means whatever modification we will perform at external level, this will not affect the logical schema at logical level. Similarly, whatever modification we will perform at logical level, it will not affect the physical level. Okay, means whatever modification user can perform in ER diagrams, okay, so it will not affect the physical levels. Means storage details will remain same. If there is any modification in ER diagram. And in the last, this is the stored database. This is the stored database. So this is known as physical data independence. So logical level modification is independent of external level, and physical level modification is independent of logical level. So this is the data independence. Let's see the detail one by one. First one is logical data independence. Logical data independence refers characteristics of being able to change the conceptual schema. Okay, in this we change the conceptual schema without having to change the external schema. Okay, in logical data independence we change the conceptual schema without having to change that external schema. Next, logical data independence is used to separate the external level from the conceptual level. Okay, so this is the external level. Okay, and this logical level we also can say it is a conceptual level also. Conceptual level. Okay, this is external level. Next, logical data used to separate the external level from the conceptual level. Now, next point is, if we do any change in conceptual view of the data, then the user view of the data would not be affected. Means whatever changes I performed at conceptual level or logical level, it will not affect the user level or external level. Okay, these are independent. Okay, so this is the logical data independence. This is the logical data independence. Okay, so suppose this is the external level. Okay, this is the external level, or you can say user level. Okay, here user can interact, the user, and there is concept, there is logical level. Okay, or conceptual level. Okay, logical level, or you can say conceptual level. So if we perform any modification, suppose this external level is modified, this external level is modified, so whether it will affect this logical or conceptual level, yes or no? No affected. It is not affected. Okay, this is the logical data independence. Okay, next is the physical data independence. Physical data independence. The physical data independence can be defined as the capacity to change the internal schema without having to change the conceptual schema. If we do any changes in the storage size of the database system server, then the conceptual structure of the database will not be affected. Physical data independence is used to separate the conceptual level from the internal storage level. Physical data independence occurs at the logical interface level. So what it means, suppose here it is the external level, here it is the external level. Next level is conceptual level. Conceptual level, or you can say logical level. Logical level. And third one is the internal level or storage level. Internal level, or the storage physical level. You can say internal level, there are various names. Physical level, where how actually data stored, or storage level, or storage level. So what physical data independence will say, if I perform any modification here, so this level is, at this level some modification is performed, at this level some modification is performed. So what physical data independence say, this conceptual level remain unaffected, means it is not affected, it is not affected. Okay, whatever modification I will perform at storage level, internal level, or physical level, at conceptual or logical level there is no modification happens. Okay, so this is physical data independence. So this is physical data independence. So conceptual data, physical data independence is used to separate conceptual level from the internal level. Physical data independence occurs at the logical level interface. So this interface is logical level interface. This interface is logical level interface. This interface is logical level interface. Okay, there is no modification at conceptual level, while if there is any modification at the internal, physical, or storage level. Next is the data models. Next is the data models. So data models are the fundamental entities to introduce abstraction in a DBMS. So it is a fundamental entities to introduce abstraction. To introduce abstraction in the DBMS. Okay. Next, data models defines how data is connected to each other and how they are processed and stored inside the system. Data model defines how the logical structure of a database is modeled. Okay, so in a nutshell, if I say, it defines the relationships between various data, relationship between data, okay, define relationship between data. Next, processing method. Okay, processing method, how they are processed, Next, how they are stored, okay, and it also defines the logical structure, or you can say logical model. Okay, all these things are defined by data model. So relationship between data, processing method, how they are processed, how they are stored, and logical model is defined in the data model. Okay, defined in the data model. So there are various types of data model. Based on these models, that depending upon the type of data, the various data models are adopted. Okay, so there are various data model. So there are basically many type of data models. Some of the important are is, first one is relational database model. First one is relational database model. Second is hierarchical database model. Third one is network database model. Fourth one is object oriented database model. Fifth one is ER model, or entity relationship model. In short, we can also say these are ER model. ER model also. These are also known as ER model. Okay. Next type is document model. Seventh one is entity attribute value model. Eighth one is star schema model. Ninth one is object relation model, which combines the two that make up its name. So relational object relation model is formed by combination of two object model. First one is object oriented model, object oriented database model, object oriented database model, object oriented database model, plus relational database model, plus relational database model, plus relational database model, plus relational database model. So this model formed by combining these two models. Okay, so the model which we will discuss is relational database model. In this model, there is concept of keys. Okay, so we have discussed various types of keys, normalization, okay, and basically in relational database model, we store the database in the form of table. We store the database in the form of table. Okay, so this is all about our various types of database model. Thank you. Jai Hind.